I realize that probability is about where it starts to get challenging in this course. So hopefully with this short video we can clear up the understandings you have so far. The first thing to know is that the probability of any event E, whatever that event is simply always, every time, the number of ways to have that happen. So the number of ways that you can get that event E divided by the total number of possibilities. Any probability we ever want to make can always boil down to simply the number of ways we can get what we want divided by the number of ways it could happen at all. Then the rules that follow shortcut a lot of counting or a lot of work in making this fraction. For example, we have the complement rule. The complement is simply the probability of not getting some event, either event A or E, I think that the online software uses. That's the probability of not something happening. So 1 is the probability of all of this stuff happening minus the probability of the thing happening. Will tell you the complement, the probability that it doesn't rain today, the probability that you don't get a date, the probability that you don't pass the course, those kinds of things. Then it boils down to two rules called the multiplication or addition rule, and the words are there in the reference page, and for multiply and or for addition. Further, the addition rule usually happens with one event, one thing. You pick one car. What's the probability it's red or black? And the multiplication rule happens with multiple events. You're going to choose 3 cards or 5 cards. What's the probability of the first event times the probability of the second event? First and second. This thing could be extended to third and fourth and fifth events. Each time there's an and, we would multiply by the next probability. Now that being said, you see this funky notation for the probability of B given A. That's a conditional probability. This happens when events are dependent. When the probability of event A affects the probability of B, we see the conditional probability here. The probability of B given that A has occurred. If the events are independent, the probability of B given event A will be exactly the probability of B. That means there was no change. This little guy A, whatever it was, had no effect on the actual probability of event B. Those are independent events. If that's the case, then we just use this right up here for independent things. If they're dependent, we use the conditional probability. Use the one that works in the problem. For dependent events, you can think of that as sampling without replacement. You take something out and it stays out. And independent events are when we have replacement, we put the card back in and then we draw another one. Or if your sample is so large that taking one element out of the sample or the population really doesn't affect the probability of choosing something similar on the next shot. So now that you know the rules and when to use them, you might have to rewrite problems in terms of these rules. You're looking for a word not, a word or, a word and, or the word given sometimes for the conditional probability. And if it's not there in the problem, then your job is to restate the problem in a way that makes the rule evident. So I grabbed this example from the homework. I think it was number 9 on the 5.7. Because it's a good instance of us using a lot of these rules and does not spell out the word right there. So in a recent year, we had 29,757 fatalities, and of them, 9,001 were related to alcohol. What's the probability that a randomly selected fatality was alcohol related? So you see that we have just one single event, one fatality, or one that we select. We want to know the probability that that event is alcohol related. So I'm just going to write alcohol there. That's our event. This is simply, like we stated earlier, the number of ways that we can get alcohol related events or deaths divided by the total. So there were 9,001 alcohol related traffic fatalities in a total of 29,757. Very simple probability assignment. Second thing we get to use is the complement rule. What's the probability that one event was not alcohol related? That the notation we would use is the probability that alcohol was not involved. The little c for a complement is 1 minus the probability that alcohol was involved, because it either was or it was not. You could count up the number of accidents that were not alcohol related. That would be 29,757 minus 9,001. Or you could simply do 1 minus 9,001 over 29,757. Now we ramp it up a little bit. What's the probability that 2 randomly selected fatalities were both alcohol related? I know that it does not say and or. Now it's your job to figure out which rule applies. So I sometimes think of it this way. We have 2 events and we want the first one to be alcohol related and we want the second thing to be alcohol related. The first one and the second. You might also notice that there are 2 events. Multiple events means usually the multiplication rule. So what's the probability you get alcohol and another alcohol-related event? The probability that you get 2 alcohol-related fatalities. Well, the probability that the first fatality was related to alcohol is 9,001 divided by 29,757. And we can go back in there and talk about a second fatality in a population of 29,757. If we take 1 out of it, it's not going to affect the probability of the next event. 9,001 out of 29,757. Or you could do 9,000. It won't change that answer. These are independent because of the large sample size. So let me pull up my calculator here and I could actually do the math that we have been ignoring. Okay, 9,000 9,001 divided by 29,757 is about 0.3025 to 4 decimal places, and 1 minus this answer. So 1 minus second, and the minus key brings that answer up again. I don't have to type it in again, thankfully. 0.6975 for the complement. And now the both. So we want that 9,001 divided by 29,757 times another 9,001 divided by 29,757. Probability is 0.0915 to 4 decimal places. The next question combines the 2 previous questions, the probability that neither were alcohol related. So we have a couple of approaches we could make to that. One of them would be the probability of 2 not alcohol, or the complement of the alcohol event. Well, again, 2 separate events, one and another one. The first one needs to be not alcohol or alcohol complement, and the second one also needs to be not alcohol or alcohol complement. I want the first thing to be not alcohol and the second event to be not alcohol related. So in this case we have a multiplication, 2 separate events, use the multiplication rule. We want one and the other event to happen in the same way we've specified. Then we need probabilities for the fatality not to be alcohol related, and we decided that to be the 0.6975, or you could write it as a fraction to remove any rounding errors. 9,001 divided by 29,757 times another 9,001 divided by 29,757. Okay, that guy was 0.0915 to 2 decimal places. That's because I forgot to use the complement, so he matches exactly. Probability is 0.6975 for not having alcohol involved. However, that guy was rounded up here, so when I use it down here, I'm going to try and go back up and get the non-rounded version on the calculator. So here we got this number, use that guy, and then multiply it by that number again. You could type it out, 0.6975165507, or you could scroll up and grab it. So that probability is 0.4865. Lastly is an at least, and those ones can be so simple and also so complicated. At least one was alcohol related. So again, we still have two events, but at least one of them is alcohol related. So remember, one fatality and another, and means multiply. Now the outcomes here would say we'd have at least one of them alcohol related. So maybe the first one's alcohol related and the second one is not. Or maybe we have the situation where the first fatality is not alcohol related and the second one is. So we have these two ways that we could get what we want to have happen. Two of them are selected, and at least one of them was alcohol related. So we could have alcohol times not, or not times alcohol, and then we would have to add them together because OR is the addition rule. Get this number, and then add them. Or we can use the complement rule. So if at least one was alcohol related, that means that we care about all the events, at least one, right? So one is alcohol related or two is alcohol related.